Hello viewers, and welcome once again. Today we are going to treat construction of table for statement form. How to construct table for statement form. Then we are going to use example to show how to construct a table for a statement form. Example: construct a truth table for P implies not Q or R. So this is a statement form. We want to construct a table for this statement form. P implies not Q or R. That is the statement form. Let's construct the table. You write the statement. P implies not Q or R. You write truth table. We know that truth table contains rows and the columns. Let us draw the truth table so that it contains rows and the table. You draw a horizontal line. You draw a vertical line. Draw a vertical line. Then let them meet. So this is our rectangular shape for the table. You draw another horizontal line to create our rows for statement. Our rows for statement. Very good. Having drawn it, we know that our statement is P implies not Q or R. There are three simple statements that are involved in this statement, form. We have three simple statements that are involved. Now, these three simple statements determine the rows we are going to create for the table. That means the ways we are going to compile the truth value of the simple statements that are involved in the statement form. And the formula to create rows or used to determine our rows to create a table is 2 power n. That n denotes the number of simple statements that are involved in the statement form. So here we have three simple statement form. That means we are going to have 2 power 3, which is equal to 8. We are going to have 8 rows. That means that we are going to have 8 possible ways we can combine the simple statement truth value. The 8 ways we are going to combine the truth value of the simple statements that are involved in the statement form. So we are going to create 8 rows apart from our first row for the statement. You create First one, first row, second row, third row, fourth row, fifth row, sixth row, seventh row, and eighth row. You can count it. You have 1, 2, 3, 4, 5, 6, 7, 8. I mean, you have 8 rows. Let's create our columns. So our 3 initial columns is going to contain our 3 simple statements. We have 1 here, 1, 2, 3. Thank you. But before we start, you know that this statement has been restored to its parentheses. It contains all the whole parentheses. If there is no parentheses, we are going to restore the parentheses. That means if there is in another form called abbreviated form, that it is in abbreviated form, we are going to restore the parentheses. But here it is in statement, the parenthesis has been restored. So we don't need to restore the parentheses. For us to know that which one is the main connective, we know that when we remove the brackets, the upper bracket, we can know the main connectives. Here, if you remove the brackets, this one and this one, you know that our all connective is our main connective here for this statement. Our all connective is the main connective for this statement. So, having known that, what we do is that we have not Q for the other side. We are going to create column for not Q and column for P implies not Q. I already have R here. R is our simple statement which we have already created here. Now see what we mean. We create one for not Q, one for P implies not Q, then the remaining one is for the whole statement. That means P implies Q or R. See what I mean here? How? Statement here, simple statements. P, Q, R. So they are our simple statements. Then we have not Q here. Fine. Then have another statement that this statement that is combined with our main connective. This statement here, we get it. We have column for that. P implies not Q. Then our full statement, P implies bracket not Q or R. So that is our sorry, there must be brackets here. So that is that. So there must be a bracket there. Sorry, I've already make sure you put it. So that is bracket that connects, that combine this not Q and P by this implies connective. Now you have 8 rows. That means we are going to combine the two values of the simple statement into different 8 ways. That means you're going to have 0 is our 1, 1 is our 2, our first row 0, second row 2, third row 2, first row 0, second row 1, third row 2, fourth row 3, fifth row 4, sixth row, first row 0, second row 1, third row 2, fourth row 3, fifth row 4, sixth row 5, seventh row 6, eighth row 7. They have now 1, 2, 3, 4, 5, 6, 7, 8. So 8 rows. Now, for us to determine how we combine our statement, how we combine our truth value for this statement. This means that we are going to convert this number into binary numbers. Convert this number into binary numbers. So number one is that if you convert this 0 to binary number, 0 convert it to binary number, it means that 2 divided 0 is 0. So remember 0. So you have only but. So the 0 base 10 is equal to 0 base 2. Now let us convert 1 to binary number. It is in base 10. That means you have 2 divided by 1. 2 divided by 1, 0. Let's mean that because we want to get a whole number that we can bring down here. So there's no whole number you can bring down. So it is, we say is 0, remainder 1. So the 2 base 10 is equal to 1. Binary number 1. Then what of 3? What of 2? We said that 2 you want to convert it to binary number. This 2 this base 10, 2 base 10 to binary number. 2 divided 2 you say is 1, remainder 0. 2 divided 1, you know that's no whole number. You write 0 and write remainder 1. That means 2 base 10 is equal to 1, 0. That means 10. Now, another idea I'll give you, if you do it the same thing, you see, let's convert 3 to 3 base 10 to base 2. 2 divide 3, 2 divide 3, it gives us 2, remainder 1. 2 divide 2 will give us 0, remainder 0. Sorry, 1, remainder 0. 2 divide 1, 0, remainder 1. That means 3 base 10 is equal to 1, 0, 1. We have now known that, we have seen that first one is 0, second one is 1, third one is 10, fourth one is 103. Now, what you understand in this number is that if we are counting numbers, those ones that involve 0 and 1, just pick them one after the other. That is your binary. That is what represents each rows under the statement, under the simple statement column. So we have 0, but knowing that we have three simple statement form. That means since we have 0, You add another 1 0, 0 0, so that you have one combination. This is your number 1 first column representative or last, depends on how you want it. Then 2, we have 1. After 0, we have 1. That is combined only 0 and the 1. So here we are going to add another 0, 0 0, so that it will be in 3. In computer, he call it 3 bytes. But let us talk about using computer jargon. Let us use our normal term. So here we are going to have, so let's make it to be in 3, so that it will represent, those 3 will represent our truth value 0 and the 1, but only that you don't use 0 and 1, you use truth and the false. That one after we then change it to truth and the false. The other one is, we have also 10 again, but after 0, 1, another number that involves 0 and 1 is 10. So this 10, but have only but 2 digits, but here how to make it to represent our 3 statements, simple statements, we add 0 again in front. Another one is 11. 11 involves in our number involve 0 and a 1. So we have 1 here, but it has only 2 digits. You add another 0 so that it can represent our simple statement form. Another one is 100. After 11, also again, but our 100. So 100 represents our normal, our 3, it represents the whole simple statement truth value. The other one is, after you count 101. 101 is another one you will count. So after 101, I count 111. 111. That is another number that involves 0 and the 1 in our number. So we count them. We have 1, 2, 3, 4, 5, 6, 7. No, it is 7. That's why we skipped. We have 00, 001, 0010, 001, 100, 101, 111. That's one that's missing. We are missing 1 there. That's one we are missing. Which one is that? Then 001, 10, 11, 1, 2, 3, 4, 5, 6, 7. Just have 8. That means, but let us see that this one represents 00 means it is F. This one means this 0 represents F. This 0 represents F. This one represents T. That means 1 represents T, truth. Then 0 represents F, and is positive. Then this one is F, T, F. This one is also F, T, T. Then this one represents T, F, F. This one represents T, F, T. This one represents T, T, T. Then the one we are missing is 110. So what are missing there? We are missing 110 there. You have got it? So what we are missing is 110. We are missing there. That means after 101, you have 110. That means you have T, T, F. Then we have our 111. That means T, T, T. Now I have gotten our all the possible combinations for our simple statement. Having gotten it, we are going to insert them in each row under the column of the simple statements. Now, see what you mean here. Let's start from the highest to the lowest. Let's start from T, 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 that means 111. It is T. Let me use red ink. It is T, T, T. Then second one is 110. It is T, T, F. Next one is 100. That means T, F, F. Next one is what again? Okay, 11. That means 0, 1, 1. 11, 0, 1, 1. That means, is it 11? We are getting TT, TTF. Sorry, 101. We have 101. 101. It is F, T. It's after 101. This one is 111, 110, 101. Then you go to the 100, which is T, F, F. Then you go to another one, the 11. That 11 is where we have 0, 1, 1. That means F, T, T. Another one is where you have 10. That means it's going to be 0, 10. F, T, F. So another one where we have 1, which is 001, which is F, F, T. Another one is where we have 0, that means 0, 0, 0. It is F, F, F. Now we have seen how we determine how to get the computation of each column by the binary number. We have used simple ways. Instead of we to start solving the binary, try to convert the base 10 to base 2, we just use our normal number. This one is okay. This one is number 1. This thing, our number that involves 0 and 1 is 0. Another one that involves 0 and 1 is 1. Another one that involves 0 and 1 is 10. Another one is 11. Now until you get up to 8 and 8 combinations before you will stop. If it is 2 power 4, I mean, because you do it, you get up to 16. So that is that. Now we know that we said that whenever not Q is true, not Q is false. That means here is T, here will be F, because it is not Q. That means not Q, and Q here is T, so not Q will be F. Here is T, it will be F. Here is F, it will be T. Here is T, it will be T. So here is F, it will be T. So here it will also be F, because here is T, it will be F. Here is T, it will be F. Here is F, it will be T. Here is F, it will be T. Now we go to this compound statement that is being combined by implies connectives. And we know that our semantics says that it can only be F when P is T, then the antecedent is T, while the consequence is F. That's when we can have Here we have only two variation for that to be 0. Otherwise, they are truth. So we look where P is T and where not Q is F. There we are going to validate it to be F. So here P is T, Q is F. That means we force here. Q is T, P is T, Q is F. That means it's going to be F here. Here, Q is T, not Q is F. That means it is F here. Here, P is T, not Q is T, otherwise that means it is true. Here is T, here is T, is true. Here is F, here is F, it is true. Here is F, here is F, it is true. Here is F, here is T, is true. Here is F, here is T, is true. The rest are, they are true. So we have true here, true here, true here, true here, true here, true here. Let us evaluate our last statement. The last one is P implies not Q. Having known our P, now you can only say that it is all that connect them, it's all that combine this statement and this one. So we are going to the semantics for all is that when the antecedent, sorry, when the two statements that they are false, that means P implies not Q is false and R is false. That means it's going to be false. And when the two simple statements or the two statements they are false, that's when we are going to have false. Otherwise, it is T, truth. So here we have our P implies not Q to be F. Here Q is T, it is T. Here it is T, here is F, so it is T. Here is F, here is T, it is T. Here is F, here is T, it is T. Here is T, here it is T. That means it is T. Here is T. Sorry, I talked about, sorry, it's R I talked about, R, not T. Now here it is F, here it is T, so it is T. Here it is F, here it is F, so it is F. That means P implies not Q is F here, then R is F here in this row, so it is F. Here it is T, here it is T. No. Here it is F, here it is T. No. Here it is T, here it is T. No. F, T, 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 F, T. No. So they are all of them are truth, except this second row. You have T, 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 T. So this is the truth table for this statement. P implies not Q implies R. So here we are going to draw our curtain. Thank you, viewers.